Welcome to this week's Short Clip Friday podcast. On Fridays, I will be posting clips from previous episodes. And the point here is just to bring you some of the highest yield topics from each podcast in order to kind of reinforce those topics. This clip is from the Thermodynamics podcast and covers the 4 laws of thermodynamics. Enjoy. All right, so let's get into the laws of thermodynamics. So I'm first going to give you kind of the straight up definition of each of these laws, and then I'll try to kind of convert that more into English and tell you what it really means, and then how to apply it, and then talk about how you may see it on the MCAT. And thermo is somewhat non-intuitive, so I'm going to do my best to make this clear. However, if you are looking for, good videos that describe thermodynamics, go to YouTube. Khan Academy is great. You can look up other videos, and hopefully at the end of it all, you can kind of get a clearer picture of what some of these thermodynamic variables mean. All right, so there are 4 laws of thermodynamics: the zeroth law, the first, the second, and the third. Let's start with the zeroth. The zeroth law of thermodynamics states that if 2 systems are in thermodynamic equilibrium with a third system, then the 2 original systems are in thermal equilibrium with each other. In other words, if system X is in thermal equilibrium with system Y, and then system Y is in thermal equilibrium with system Z, then X and Z are also in thermal equilibrium with each other, which it brings me back to like those 5th grade math properties. I forget whatever it's called, but like the transitive property or whatever. Anyways, so, take 3 objects, let's say your hand, a metal pan, and a stovetop burner, right? So if you turn that stove burner onto high, you put your pan on there, and then you put your hand on there, eventually, and probably pretty quickly, all 3 will be the same temperature, right? At which point you can say they're in thermal equilibrium. So this is just saying that if your hand is in thermal equilibrium with the stovetop, then the pan must be also in equilibrium with both of them, which makes sense, right? This is a pretty easy law to understand. And I don't think I've seen this law come up too much on the MCAT, but I could see a scenario where maybe they give you 3 bodies that are in thermal equilibrium and, in a passage or something, and then they say, which law of thermodynamics does this scenario apply to? So I could see something like that, but this one is probably less important than the other laws. So let's get on to the first law of thermodynamics. The first law says that thermodynamic energy, which is heat, can neither be created nor destroyed, just transferred. So you'll see an equation that goes along with this that is delta U is equal to Q plus W, where delta U is the internal energy, Q is heat, and W is work. And what this equation is saying is that the change in internal energy of a system is equal to the heat input plus the work done on the system or work done by the system. So it's saying that a transfer in internal energy is either due to, number 1, the input or output of heat directly, or by work that's either done on the system or by the system. So to increase the internal energy of a system, you have to input heat or input work. And so you can see here, you can't create this internal energy. You have to basically transfer it from somewhere else into this system. So that's kind of what the first law of thermodynamics says. It's a conservation of energy law. And you'll probably see this a few different ways on the MCAT. The first is asking questions related to that equation. Delta U is equal to Q plus W. And so W can be calculated, again, which is work, can be calculated as P delta V, or pressure times the change in volume. This is known as constant pressure work. So the first type of question I could see them asking is something in which you have to manipulate this equation, delta U equal to Q plus W, in order to solve for something. So, maybe they give you a passage where they're talking about the lungs and they're talking about a change in volume as you inhale, and then you're asked to calculate the heat. And it tells you in the passage the internal energy change is 0. So in this case, you'd set this equation to 0, and you'd have Q plus W is equal to 0, and then you put in P delta V for work, and then you just go through and you solve for the Q using the pressure they give you, the change in volume of your lungs, and then you solve for that Q. So these would be pretty easy calculations to do. It's just knowing that equation. You also might be asked to identify the actual definition. So, they might talk about conservation of energy or conservation of thermal energy in a passage and then ask you, which law of thermodynamics is this, which the answer is the first law. All right, on to the second law of thermodynamics. This law states that the entropy of an isolated system always increases. And you may see this also as the entropy of the universe always increases, because the universe is kind of the ultimate isolated system. And your Gen Chem teacher might have told you a story about how, what happens after you clean your room? Well, eventually your room becomes messy again because entropy must increase. What I like to think about is you take two gases. So let's say I have gas A in my right hand, gas B in my left hand, and now I mix those gases. So what I just did is I increased the entropy, right? I increased the disorder because I mixed these two gases together. Now I dare you to take this mixture of gases and pull each gas apart back into each hand. It's impossible, right? This process of taking a mixture of gases and pulling each constituent gas out of it is a decrease in entropy. So you can see, obviously, the universe tends to favor these processes that increase the entropy. It just seems more natural, it's kind of a weird concept to really look at. But just know for isolated systems, entropy is always increasing. In terms of the MCAT, you might see this as definitional. So again, this is the second law of thermodynamics. Or you might see something where they throw in something like delta S universe is greater than 0, is less than 0, equal to 0, as part of an answer. Well, just know that the right answer has to be that the delta S universe is greater than 0, right? It's always increasing, so it's got to be greater than 0. And I actually had a friend, or I guess probably more of a peer in college, who actually got a tattoo, and I'm not even doing a bit. This is real. He had a tattoo that was delta S is greater than 0 on his calf. And I think it was supposed to be kind of like a deep metaphor for something, but anyways, I'll never forget that delta S is greater than 0 because I sat behind him, so I was forced to look at it every day. All right, on to the third and final law of thermodynamics, and that is that the entropy of a pure crystalline substance at 0 Kelvin is 0. And all this is doing is basically giving you a reference point so that you can determine absolute entropy instead of just change in entropy. This basically sets that 0 point. It's like being able to say, today it is 35 degrees Celsius, instead of just saying, oh, today it is 3 degrees warmer than it was yesterday, or we had a delta T of 3. Right? This gives you a reference point, like Celsius, which is a freezing point of water, is 0. So it gives you that reference point so then you can set absolute values. And there's an equation that goes along with this third law, which is that entropy at some phase change is equal to the enthalpy of that phase change over the temperature of that phase change. And phase changes occur at a single temperature. I'll talk more about this in a little bit, but just know that that equation goes along with it. S is equal to H over T. And so where will you see this on the MCAT? Well, you'll see it in terms of the definition. You'll want to know this is the third law of thermodynamics. And then you'll also probably see some kind of calculations regarding a phase change. Maybe they give you enthalpy, they give you temperature. You got to calculate the entropy, which is that S equal to H over T equation. So it's important to kind of keep in your back pocket for use, but really a simple calculation. So let me just quickly summarize these 4 different thermodynamic laws. The zeroth law has to do with equilibrium between bodies. If X is in equilibrium with Y, which is in equilibrium with Z, then X and Z are in equilibrium with each other. The first law says that energy is always conserved. Specifically, thermodynamic energy is always conserved and cannot be created or destroyed. The second law of thermodynamics says that entropy is always increasing in an isolated system, or that delta S is greater than 0. And then the third and final law of thermodynamics says that the entropy of a pure crystalline substance at 0 degrees Kelvin is equal to 0.
At Med School Coach, we know that getting into medical school is hard. In fact, 60% of pre-meds who apply to a medical school don't even get accepted. And if you want to get accepted into a top medical school, it's even harder. That's why more students than ever are turning to MCAT Tutoring by Med School Coach. Our tutors are all 99th percentile scorers, have been through rigorous training, and can help raise your MCAT score by 12 points or more. You need every competitive advantage you can get to get into med school, so why not get one-on-one tutoring from Med School Coach? Our expert team will create a custom program just for you and help you master MCAT content where you need the help most. You'll raise your MCAT score. We guarantee it. Visit us online at medschoolcoach.com and use offer code PODCAST10 to save 10% up to $400 on a Med School Coach MCAT tutoring package. You can achieve your medical school dreams, and Med School Coach can help.